Okay, so here's our objective. All right. And the way this is set up is you're going to see I'm going to have some notes here. All right. Now, here's one. The time distance for your property displacement graph or displacement graph where it's a flat line. All right. Here's my flat line. So what would my time velocity graph look like? That's going to be like that. Okay? Because a flat line on a displacement graph means no motion. So my velocity graph will be at 0. Okay, the next one. I've got a constant positive slope. These are straight lines. They're a little curved, but I meant to draw them straight. What would that look like on a velocity graph? This is 0 again. The steeper the line, the higher up it is. But since they're straight, it'd be a constant v. Constant positive v. All right? Now the opposite, so to speak, is a constant negative slope. Therefore, they're going to look like this. A is going to be flat further away from the axis, and B is going to be closer. Like that. All right? Now the next thing, the time distance graph is getting steeper, but it's a positive. That means it's getting to go like this. These are constant A. All of these are a constant acceleration. A is constant for all of them, for these next 4, all right? The line's going to get away from 0 because it's gaining speed. Now, if it's getting steeper, but it's got a negative slope like this, that's going to look like this. It's going to slope down, all right? Now, since these are both constant acceleration now, these lines are straight. This is when the object's speeding up, both of these. All right, speeding up is moving away from these axes. All right. Now, when it's getting less, it says getting less steep. What's it going to look like? Well, that's going to go like this. It's going to go towards 0, not away from 0. And if it's getting less steep but positive, but negative, so it's getting less steep but a negative slope, that's going to look like that. All right? All right. Let's say I've got this position graph up here, and I've got these bumps. This is like a ball bouncing. I'm going to break it up into sections, A, B, C, and D. Now you'll notice this is the line getting less steep, but it's moving up, so that's this. Okay. Then here it changes its direction, so that means it's going to become negative. Here it's getting more steep, so it's going to go down. All right. Now it changes direction rather fast. It's not going to go up as high, and then it's going to come back down like that. This section is A, this section is B, this section is C, and this section is D. And I stopped it at 0 because just saying it goes like that, flattens. So that's why it comes back and flattens. Now really this should be evenly spaced, like I drew it too crushed. I should draw it a little better. It'd be there, and I mean these increments should line up like that. All right, that's an example. Here's another one. All right. Okay, flat, that's 0 velocity, so we're going to draw this down. 0. Now it's going at a constant negative. constant negative, then it goes back to 0, it goes up, then it's a constant positive, and then it's back. Oh, I drew this a little too long, but that's okay. Then this should be a little crushed together. This is a little too wide, that section. So A, B, B, C, C, D, D, E, E. Okay? Now the final one. I tried to make this one a little harder. All right. A, B, C, D, E, and F. So right here, it's getting steeper, it's gaining velocity, and then it starts to get less steep. So then it goes back down, and it gets a little like, line that up. Here's that. And then at C, it stops. Then at D, it has it's got a pretty steep constant negative. So stops for a little bit, then it's constant positive. All right. That's what that would be. All right. Let me know if this helps, and let me know if you have any questions. All right. Bye.